This is Miss Pi doing the polar test review. I am starting at the end and working my way to the top because in class today we got through all but the last couple questions, and my students didn't want to have to watch the whole video to see the last two questions. So for those of you that were absent, watch the whole thing and just start on the last problem and work your way to the first problem. All right, let's go ahead and get started. We've got a complex binomial with an I in here, and it's raised to the fourth power. And we want to put this in rectangular form, I believe, or yeah. We want to simplify it and put it in rectangular form. All right, so now to do that, we need to first find our R value and our theta. And for R, we're going to take this negative root 2, and this root 2 here, and we're going to square root those terms and square them. So this is what we're going to do to set it up. Well, both of those, once you square them, they just give you 2 plus 2, and which equals the square root of 4, which then is just 2. So our R value is 2. And then to find theta, we've got to do our inverse tangent, and that's going to be our imaginary number, the number attached to the I, divided by our real number, so square root of 2 divided by negative square root of 2. And with that, you get inverse tangent of negative 1. That is on our exact value table. So if we pull up our exact value table, go down to the tangent column, you'll see a negative 1 here, and you will also see a negative 1 here. Okay. So which one do you want to use? Well, we can either use 7 pi over 4, or we can use 3 pi over 4, and it will help if you remember that if your x is negative, you have to add pi to that. So honestly, like if you look back over here, if this is our real number, we're going on the negative x-axis. This is our positive, or excuse me, this is our imaginary number. So on our graph, we would be in the second quadrant. We would be up here because our I is positive, okay? So if you can remember that, then it might help you to figure out which one of your values on your polar coordinates or on your exact value table you're going to use. And so for quadrant 2, we are going to want to use 3 pi over 4, because if we use 7 pi over 4, then we're in quadrant 4. Okay, so we end up with 3 pi over 4 because we're in the second quadrant. And then, and I know that's probably weird, and some of you are probably saying, hey, but we didn't add pi to it. Sometimes don't worry about the pi. Sometimes if you're in like quadrant 2, it'll be okay. And the biggest thing I can tell you is with the multiple choice test, check and see what answer choices you have. And if you did use 7 pi over 4 and you don't get the correct answer, then go back and change it to 3 pi over 4. All right, so let's move on from there. So now we have R and we have theta, and we're going to set up the polar coordinates. Okay, so this would be R times cosine of your theta plus I times sine of theta. And so R is 2 and theta is 3 pi over 4. But then you have this exponent here, okay? And so that's all raised to the fourth power. We can distribute that, is essentially what we're doing. So instead of just 2 here, we're going to have 2 to the fourth power here. And then when we're distributing it throughout the parentheses, we are going to be multiplying our theta by our exponent. So it's just 4 times 3 pi over 4. Okay, what happens is the 4's cancel out, so you end up with 3 pi, and 2 to the 4th power is 16, and, at 3 pi, you're right here on the negative x-axis. Okay, so cosine of 3 pi is -1, and sine of 3 pi is just 0. So when you do 16 times -1, you get -16, and I times 0 is just 0. So your final answer on this one is just -16. Okay. For those of you that are curious, if we used the 7 pi over 4 here, let's say we put 7 pi over 4 here, and here, and here, and then we distribute the 4, and we would have 7 pi instead of 3 pi. So what would happen is here's 1 pi, here's 2 pi's, 3 pi, 4 pi, 5 pi, 6 pi, and then 7 pi, you're right back at the same location as you were with 3 pi. And that's why I said at the beginning this time, it doesn't matter whether you use 7 pi over 4 or 3 pi over 4. And I guess technically I should tell you that we should have used 7 pi over 4, but I knew ahead of time that it was going to give me the exact answer anyway. So yeah. Moving on. Let me do that. There we go. All right, so number 22. We have a complex solution divided by another complex solution, okay? Again, we're going to have to find our radius for the top formula and our radius for the bottom one. So R1 is going to be for the top, R2 is at the bottom, and we're also going to have to find theta 1 and theta 2. Okay, and so to find our R value, it's the same formula we've been doing a million times since, like, what, Algebra 1, middle school? A squared plus B squared equals C squared. Okay, so -6 squared plus 4 squared gives us 36 plus 16, which gives us 52. And the square root of 52, if we plug it all into the calculator, we're going to get decimals, but we can reduce that. And 52 is just 4 times 13, and the square root of 4 is 2 times 13. So my first radius, my R1, is 2 divided by, or times root 13. Now for our second radius, we would have the square root of 1 squared plus 4 squared gives us 1 plus 16, which gives us a square root of 17, and you cannot reduce the square root of 17. And then for theta, we're going to do inverse tangent of 4 over -6, which is inverse tangent of -2/3. And with this one, when you plug it in, go ahead and just plug it into the calculator, and it'll give you a long answer. And if you're in radians, you're going to want to add pi to that. So I added pi to this. If you're in degrees, whatever, you might have a different answer, but you would add 180 to it. Okay, so our inverse tangent of that value is approximately 2.6. And please, 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 when we do the other calculations, don't just type in 2.6 in parentheses. Go ahead and scroll up on your calculator, highlight the full answers with all the decimals, and use that when you do the inverse, or when you do cosine and sine. Okay. All right, so now for our second theta, we have inverse tangent of 4 over 1, which is just 4. We plug that in, and we get 1.33, and you don't have to do anything special with that because your x value is positive here. All right, so now when we're plugging that all in, because we're dividing here, you're going to divide your two R values, and then you would be subtracting the two thetas here. Okay, so it's very similar to when we are multiplying our two binomials. The difference is we divide our values here and we subtract in here. And again, have the calculator do all the work for you. Because the reason why is because you end up, once you multiply this 1.75 to whatever you get with cosine of 1.23 whatever and sine of 1.23 whatever, you end up with whole numbers, okay? So if you are not getting the exact same answers as any of the multiple choice, it's because you typed in a rounded calculation instead of using the full calculation. All right, so then when we multiply, we've got, or sorry, cosine of all that is 0.34 something, and sine of all this is 0.94 something. We multiply by 1.75, and we end up with this, okay? But I went ahead in my calculator and I approximated it to a fraction, and it gave me some pretty neat fractions. So if you get something like this and all the answer choices are in fraction form, go ahead and approximate to a fraction. So to do that, let me see if I can show you how to do that really quickly. I might have to do some of the calculations. Let me see, I'll just do the calculations. Let me make my calculator file smaller. There you go, you should be able to see it. All right, let's go into calculate. I am in radian mode, and so let me just do some of these calculations super fast. I need to do inverse tangent of 4 divided by -6. Okay, it gives me that. I'm going to add pi to that to give me my correct value there. And then I also need to do inverse tangent of 4, and I get that. And then, so when I'm doing the cosine of this value, do you see how I'm using my arrow keys to just highlight the answer, and I'm using the full answer there? I get that, okay? And then when I multiply my answer by my 2 times √3, root 13, divided by root 17. Okay, so notice that every time I had a decimal, instead of writing a decimal form, I highlighted the full decimal and used the full decimal. So now I get my original answer of 0.59 if I was rounding to 2 decimal places, but it's not. All the answer choices are in fraction form. So I have this. I'm going to go to menu and go to number, and you have this option of approximating to a fraction. Okay, and so as soon as you get that answer, just approximate it to a fraction. If it's a nice fraction like 10 over 17, leave it as 10 over 17. But if you had, like, let's say you had 0.58 and I don't even know what that fraction would be, approximate to a fraction. Notice it's giving us completely different fractions because I was rounding there. Even if I rounded up like I was supposed to, so I should have rounded up, which would be 0.59, and I approximate to a fraction. Okay, that's still not giving me the correct fraction that I got right here. Okay, so when you are doing calculations with previous calculations that have tons of decimals, don't just type in like 0.59 here. Use the full thing, okay? All right, let's go back to our review. All right, so that was problem 22, 21. Here we have the same type of problem except we're multiplying instead of dividing. So we're finding our R values, same way we have, finding our thetas. And when we set it up, notice we're multiplying here and we're adding here. Okay, down here on number 22, we were dividing, so we divided the radius and subtracted there. Okay, so this time we're adding the same basic concept, except I think this one we end up with a nice like pi over 6 and 5 pi over 3. So those are from our trig tables. And we end up with 11 pi over 6 here and here. So when we plug those values in, or we look them up on their trig table, we get square root of 3 over 2 minus 1/2. Distribute that 8, and we get 4 times root 3 minus 4i. Okay, so that works out that way. And one thing I did not show my students in class is that you could have also just FOILed this. However, a lot of you will make mistakes with foiling, especially with these I values. Okay, and here's why. Notice if you multiply root 3 times 2, you get 2 times root 3, which is fine. Root 3 times negative 2 times I times root 3 gives you negative 6i. And the reason why we got the 6 is root 3 times root 3 is just 3, and then 2 times 3 is 6. So that gives you negative 6i here. And then I times 2 is just plus 2i. And then I times negative 2i times root 3, notice that became a plus 2 times root 3. And the reason why is because I times I is I squared. I squared is negative 1. And negative 2 times negative 1 is a positive 2 root 3. Okay? And then with this, if you had just combined like terms and you did everything correctly, then you would have 4 times root 3 minus 4 times I here. This only works if you don't make any mistakes. You have to be super careful when you're foiling or boxing with complex solutions. All right, moving on, number 20, writing this in rectangular form. First thing we need to do again is, with this is just figuring out the cosine of 2 pi over 3. Use your trig table. So 2 pi over 3 for cosine, it's negative 1/2. For sine, it's root 3 over 2. So this cosine of 2 pi over 3, I'm replacing that with 1/2. Sine of 2 pi over 3, I'm replacing with root 3 over 2. I can then distribute my r value that's out front. Okay, I'm just going to distribute it, and that gives us this. If your choices are all in exact answer form, then don't put this in the calculator. If you see decimals, go ahead and put it in the calculator. So here, the only thing we have left to do is multiply the root 13 times root 3 gives us root 39. All right, number 19, write this in polar form. To do that, we have to find our r value. If you set it up correctly and do all the work correctly, you get the square root of 34 for that. And then we also need to find inverse tangent. It's square root of 17 over square root of 17, which is negative 1. And hopefully you realize we're in quadrant 4 for this, because if we have our imaginary, our real axis is here, our imaginary one is up here. And so we would have positive square root of 17 would be over here, and then negative 17 we would be somewhere over here. So we're in the 4th quadrant, okay? So with that, we need to, when we look on our trig table, this is, let me see, the 3rd one, yeah. This is our tangent column. We're looking for negative 1 that's in the 4th quadrant, so we would be using 7 pi over 4. So our angle that we're going to use is either 7 pi over 4, or if our answer choices use degrees, then we would just use 315 degrees, because 7 pi over 4 is equivalent to 315 degrees. All right, so depending on what type of answer or what format your answer is in, it might have 7 pi over 4 here and here, or it could have 315 degrees here and here. The format, though, for your polar form of complex solution is your r value times cosine of theta plus I times sine of theta. Okay. All right. For number 18, find the absolute value. That's just checking to see if you realize that your r value is the absolute value of this. And so you're just looking for r. You plug everything in. Hopefully you can do the math correctly at this point, and you end up with the answer being the square root of 33 here. On this one here, plot each point in a complex plane using polar coordinates. So our radius is 6, and our angle, so the biggest thing is just figuring out what everything stands for. This is your R value. This is your theta. If it's a polar graph, it's super easy. You find theta, which is pi over 3 right here, and our radius is 6. And normally you'd say, okay, 1, 2, 3, 4, 5, 6. We're way over here. But if you look on your polar axis, notice it tells you that each of these circles counts as 2. So pi over 3 would be 1, 2, 3. Our dot would be right there. Okay. Let's see, 16. We just did 17. Again, imaginary solution. Hopefully you realize that this is the real number. This is the imaginary number. Okay, so on the real axis, it's 1. On the imaginary axis, it's 3. So your point is right there. You're done. All right, number 15 with this one, I think the instructions are for these. Consider each polar graph, write the equation. On this, it is multiple choice. So you'll have options here, and hopefully you'll be able to figure this out without having to actually graph it. The biggest thing is checking out what the radius is. So on here, your radius for these is 6. So which one of those problems do you think has a radius of 6? And it would be this one. Also, you can check your petals. So if I have 4 petals, that means I have an even number, and it would be whatever that number is times 2 would give me 4. So my number here would have to be a 2. Okay. That's all you have to do for this graph. Or if you're not sure, you can always graph it. With these two, I'm going to go ahead and uncover both of them for 13 and 14, and we can look at both of these. Here, notice that your radius here is 3, and then on this, notice your R values are squared. Okay, this is the type of shape you get when you have R squared. Okay, hopefully most of you has already figured out that 3 squared equals 9, and the only option here is, or the only option that has a 9 is this first option here. Okay, if you're not sure, go ahead and graph this on your calculator. Okay, and then on this one, on number 14, hopefully you remember if it's an R squared here, you're going to have this little infinity symbol, your figure 8. So it can't be that one, can't be that one, and it can't be that one. If you're not sure, if you've forgotten that, check out your radius is 4, and the only one that could possibly have a radius of 4 is this one here. So this is the polar graph. All right, number 12, let's see, what are the, okay. Consider each polar equation, determine if the graph is symmetric with respect to the origin polar axis or the line pi over 2. I will also say some of them you could also find the symmetry if it's symmetric to the line pi over 4. So with this one, the best thing and the easiest thing to do would be to graph it, and it really doesn't matter whether you're graphing it on a polar graph or on a rectangular graph. You should be able to graph it and look at it. Another thing that's good to remember is what each thing represents. So your origin is the same origin on your rectangular graph. So that's that little dot right there. And then the polar axis on the polar function, or the polar graph, your polar axis is the same as what your x-axis would be on a rectangular graph. And then the line pi over 2, that's your y-axis. That would be this line right up here. And then the line pi over 4 would be your, I'm trying to do pi over 4. Okay, so the line pi over 4 would be this line here. Okay. So with this graph, this formula, the 4 times sine times 2 theta, you've got every type of symmetry out there under the sun. So you've got you're symmetric to the origin, you're symmetric to the polar axis, you're symmetric to the line pi over 2, and you happen to also be symmetric to the line pi over 4. There's lots of symmetry with this graph. And let me delete that one. So you're symmetric to all of them. And notice this one said pi over 2, and I changed it to 90 degrees. It's the same thing. Okay, with this one over here, you're only symmetric to the polar axis, okay? The biggest thing is remembering that this line is the polar axis. And that's what we have, symmetric to the polar axis right there. All right, let's look at the other two. Now 9 and 10, they actually give us the graph and they just tell us what it's symmetric to, which is nice. We don't have to graph these. So this one, we're symmetric to the line theta equals 90 degrees or pi over 2. And I think that's it. We're not symmetric to the origin. We're not symmetric to the polar axis. So it's just symmetric to the line 90 degrees or pi over 2. This one, it's kind of a trick question. They don't tell you that there's an option to not be symmetric at all, but hopefully you guys in the past have seen graphs that have no symmetry. So this graph, it has no symmetry. All right, number 8, I'm going to try to hurry and finish this. We are converting each equation from polar to rectangular form. Let's do number 7 first, and then we'll look at number 8. So with number 7, the biggest thing in rectangular form, you have your function has an x and a y value. So what trig function has x and y, or is equal to the ratio with an x and a y in it? And that would be your tangent. So we're going to say tangent theta, or tangent of 30 degrees, is equal to y over x. And then go ahead and pull up your trig table. Let's see, tangent of 30 degrees would be root 3 over 3. Okay, so then I'm replacing tangent of 30 degrees with root 3 over 3. So I now have y over x is equal to this. But in your standard form of your functions, you have y is equal to everything else. And so x needs to be on the other side. So we're just multiplying both sides by x, and this is what we get. Okay. With example number 8, the biggest thing is we've got to be able to get an x and a y value. And we've got to be able to get rid of our sine theta. Okay, so if I multiply both sides of my equation by r, then I'm going to have r times r is r squared, and all of this is equal to negative 4 times r times sine theta. And hopefully you remember that r squared is equal to x squared plus y squared because of the a squared plus b squared equals c squared. And then r times sine theta is just equal to our y variable, And then, again, we need to go ahead and set this format up in the correct format, or set our equation up in the correct format. And this is because we have an x squared and y squared, this is going to be a circle. And so the correct format would have everything on one side, or all your variables on one side, and you would have your radius on the other side. So I need to go ahead and move everything over, and then I have a 0 here. And then my next step would be to completing the square here. So to complete the square, I need to take this 4, and I'm going to divide it by 2, and I'm going to square it. So 4 divided by 2 is 2, 2 squared is 4. So now when I complete the square, this x squared is just going to be by itself. But I'm going to add 4 to this side to complete this square. But when I add 4 to one side, I have to also add 4 to the other side. Okay? Now I can write this in the correct order, or correct format. X squared is just going to be x squared plus, and then y plus 2 squared, and then equals 4. Now some of you are like, hey, how'd you get the squared here? Or the 2 here, excuse me. And it's, hopefully you'll remember that it's always, when you're completing the square, this number here is always going to be the number that you're going to have right here. Okay? All right. moving on. Number 6, convert each equation from rectangular to polar form. So this is going to be a lot of work, guys. Sorry. I've got to replace my x with r times cosine theta and my y with r times sine theta. Okay, so I've replaced my x's and my y. But then I need to go ahead and I have a binomial here that's squared and a binomial here that's squared. I need to FOIL or box everything, and I get it all written out here. So let me break this up. So right here, so all of this here is foiled or boxed. And then everything else here is all of this. And then it's equal to 5. Okay. Once I do that, let me get rid of that red line. Once I do that, I'm going to reorganize everything. Whoa, I did not want to delete everything. I hope I did not delete everything. All right. I'm going to organize all my squared terms together, and everything else is going to eventually get to the other side. So this time I just reorganized all the stuff that was on the left side. Notice that my 5 here became a 0. And the reason why is because I have this 1 here and I have a 4 here, and I just subtracted those and moved them over to the other side. Okay, now all of this stuff here I'm going to move to the other side. So this negative 2 times r times cosine becomes positive. This positive becomes negative. Okay, hopefully by now you remember that cosine squared theta and sine squared theta, if I factor out that r squared, I can replace that with something super nice and pretty because that just equals 1. So now I have r squared. I'm going to do it this way. There we go. So I have r squared is equal to all of this stuff over here. And then I can divide everything by r because I have r on both sides of the equation. And then what happens is I get r equals 2 times cosine theta minus 4 times sine theta. All right, number 5. I'm converting this equation from rectangular to polar form. Again, I'm going to replace my y with r times sine theta, replace my x with r times cosine theta, but because x is squared, I also have to square the r and the cosine theta. And then I want to get my r values all together and everything else on the other side of my equation. Okay, so that's what I'm going to do here. I'm going to multiply both sides by 4 so I can get rid of this 4. I'm going to divide both sides by r to get rid of this r here. And I'm going to divide both sides by cosine squared theta to get rid of the cosine squared theta here. Okay, so that's what I do. This r cancels out this r. This squared, or this r cancels out the squared. This 4 cancels out that 4. And this cosine squared cancels out this cosine squared. So I end up with r on all by itself. Okay. And then what I have left over here is 4 times sine theta times cosine squared theta. But that cosine squared theta, I can separate that by just doing cosine times cosine. Okay, and most of my students by now are saying, hey, I can replace this right here with tangent, and I can replace this with secant. And so our r is going to end up equaling 4 times tangent theta times cosecant theta. Actually, you know what? This should say secant theta. Sorry, that's a typo. Let me fix that really quickly. There we go. The reciprocal of 1 over cosine is secant theta. Glad I caught that. All right, moving on. We are almost done, guys. Number 3 and 4, we're converting between polar coordinates and rectangular coordinates and back and forth. So For number 4, this is our r value, this is our theta, so we've got to find x and y. So for x, it would be r times cosine of theta. I'm just plugging in my sine, or my angle, and my radius in there. And then, so my radius of -3 is going to stay the same, but cosine of -pi/3 is, so positive pi/3 is 60 degrees. So -pi/3 would be what, 330 degrees, is that right? No, it would be 300 degrees because I'm subtracting 60 degrees. Yeah, so it would be 300 degrees. So cosine is going to just be 1/2, and sine, just for future reference, would be -√3/2. All right, so I'm going to have cosine of -pi/3 is 1/2. I multiply that by 3, I get -3/2. Now for my y value, do kind of the same thing. I'll do -3 times sine of -pi/3. And like I said earlier, that was equal to -√3/2. So because I have a negative here and a negative here, it's going to become positive 3√3/2. Okay, so my coordinates for that would just be this. Okay. Now to convert from rectangular coordinates to polar coordinates, I have to find my r value and my theta. I've done that a million times. I'm not going to go over it again. This is r, this is theta. And notice there's 2 ways you can do this. You can realize that you're in the 4th quadrant with this, and so you would, or not 4th, your 3rd quadrant with this, and so you would use your angle that's in your 3rd quadrant. So in this case, we had √3. We were doing inverse tangent of √3. So inverse tangent of √3, well, it could be pi/3, or it would be 4 pi/3. But because we are in the 3rd quadrant, we want to use 4 pi/3. If you remember it, that's all you have to do. If you forget, then hopefully you would realize, hey, your x is negative, so you would have to add pi to the √3, or to pi/3. Anyway, in either case, your r value is 2, and theta is 4 pi/3. Okay. Problem 2 is our distance formula. We have 2 points, and this is in polar coordinates. Sorry, these are the polar coordinates. And so hopefully you remember your distance formula. That's this. On the test, I will most likely give you guys a copy of the trig table, a copy of, you might have access to some trig identities, probably not all of them, but some of them you might have access to, and then you will probably have this distance formula somewhere, maybe. If I don't put it on in the worksheet or the paper for you to use on the test, or the note sheet for you to use on the test, I might just have it written on the board somewhere. You'll just have to look around. All right, so for our distance formula, again, you have to use r1 and r2 and theta1 and theta2. But the nice thing is, because these are polar formula coordinates, they give it to you. So you just plug in everything that you need. And guys, please, please, please put this in the calculator. And some of you might be concerned about messing this up by, using the wrong angle. I just wanted to show you that it doesn't matter which is theta1 and which is theta2. If you did 345 minus 45, you would get this answer. If you did 45 minus 345, you would also get the same answer. So either way, you'll get the same answer. Alrighty, let's see, what else do we have to do? Oh, last one, plot the point of the given polar coordinate. And we have 11 pi/6. Here's our 11 pi/6. So most of us would say 2 is right here, but that would be wrong because we have a -2. So that's wrong. So we want to keep on going on this 11 pi/6. And it would be right here. So 5 pi/6 is our coordinating side. And we want -2, so our point would be right here. Okay. All right, that is the end. Sorry if it confuses you guys because I went backwards, but I did it for the students that were in class today so they wouldn't have to watch the whole video if they didn't want to. All right, good luck on the test.